Hello all. Here in this part, we will see the simplification of Boolean expression using K-map. In part 1, we have seen the structure of K-map, how we will design a 2 variable, 3 variable and 4 variable K-map. That was in part 1. In this part, we will see the simplification of Boolean expression. For the simplification process, the step 1 will be grouping. How we will do grouping? Once we plot the logic function or truth table on K-map, we have to use the grouping technique. In first part, we have seen how we will make the entries in the K-map. After doing entries, we will go for the grouping. We have to make the group of adjacent ones that is enter in our K-map. We can make the grouping in the binary rule, that is in the number of ones will be 2 to the power x. Then we will make the group of that number of ones. Means we can make the group of 1, 2, 4 and 8 and so on, number of ones that are adjacent to each other. How we will see the adjacent? Suppose this is our K-map. We have the 3 variable K-map here. Here it is the first block, second block, third block, fourth block, fifth, sixth, seventh and eighth block. So for making the pair, or how we will say it is adjacent? This 1 and 2 is adjacent, this 1 and 5 also adjacent, 2, 3 adjacent, 4 and 1 will be adjacent. How we will see 4 and 1 adjacent? We will see in this group, in this K-map. I have given here it is circle and here it is circle. So we will make the group of these ones. If 1 is enter here, 1 is enter here, then we can make the group of this. Here it is star. If in this position 1 is enter, then we can make pair of it. Here it is cross, here it is cross. If there is 1 in this block, we can make pair. Here it is triangle. If ones are adjacent vertically to each other, then also we can make the group. In this 4 variable K-map, if 1 and 4, 2 and 3 will be adjacent, 1 and 2 adjacent, 9, 10 will be adjacent, 7 and 11 will be adjacent, 6 and 10 will be adjacent. Here 10 and 14 will also be adjacent and 14 and 2 also will be adjacent. The K-map will work on the rolling basis. Why it is so? In Boolean algebra, you have seen this law, a plus a complement will be 1. Here the value of a will be 1 and a bar will be 0. If we have this 2 mean term, then we can make this is equals to 1. You know? How here you can say that here it is 0 0 means the value of b and c will be 0 0, and here it is the value of bc. So the value of b and c will be 1 and 0. If we will take c as a common, C complement as a common, so there will be value 0 and 1, that is b complement and b. Okay, so b complement plus b will be equals to 1 and 1 dot c, that will be 0, that will be c complement. Okay, so we can make the pair of 4 and 1. The example, when we will see the example, that will be clear to you. Okay. Now how we will make the pairs? Suppose this is our Boolean function, a complement bc plus a complement b c complement. How we will enter it? We will make entry in the block of a complement bc 1. This is the block of a complement bc. This is the block of a complement b c complement. We have made entry 1 1 here. Okay. So we can, this one are adjacent, so we can make a pair of it. After pairing this one, how we will give the minimized expression of this pair? Okay. If we will solve this Boolean expression with the laws. So here we have taken common, we have used distributive law here, a complement b, a complement is common here. We will use a distributive law here. In the brackets there will be c plus c complement. This is equivalent to 1. So the minimized term will be a complement b. Here it is through Boolean laws. Now how we will see it from the pair? See, in pairs, in pair or in group, we will see that which variable is having the same value in both the terms. Okay, and which variable will be changed from its original value to complement or complement to original value, that variable will be absorbed. In this K-map we will see, in this pair we will see the value of A complement is same in both the block. The value of B is also same in the both the block, but the value of C is changing from C to C complement. So we will absorb the variable C and the minimized value will be A complement B. Here it is A complement, here it is B. So the minimized term for this pair will be A complement B. Okay. For next group, suppose the variable function, suppose the Boolean expression is A complement B complement C plus A B complement C. So we made the entry here A complement B complement C, A B complement C. Now we can make pair of it because these one are adjacent. Okay. Now see how the Boolean minimized expression for this pair. Suppose here the value of A is changing from A complement to A, but the value of B complement and C is as it is. So the we will absorb this A and the minimized function will, minimized expression will for this pair will be B complement C. Okay. Now this is other examples of pair. We can make the one pair of this. We can make pair of this. If the entries are like this 1 1 1, so we can make pair of this and also we can reuse this one. Why it is so? Remember the Boolean law. If we can use A dot A is equals to A, or we can say X dot X is equals to X. Okay, so we can write a mean term or a variable 2 or 3 times. So suppose we have written this ABC 2 times. Suppose ABC plus ABC. Okay. So that's why we can use this one, we can reuse this one, or we can use any one 2 or 3 times if it is required only. Okay, you can say that this one and this one is also adjacent. Okay, so if we will make the group of this one and this one, for this one we have to make pair of this, for this one we have to make a pair of this, and suppose if we will make a pair of this also, then a extra term will be added, the extra term will be added to our minimized function, minimized expression. So this extra term is known as redundancy term. So we will avoid this type of redundancy. Here it is the variable, here it is the 4 variables K-map. Now how to group chord? How to group chord? Okay, if this type of ones are adjacent, so it can make a chord. If this type of ones are adjacent, then we can make chord of this. What will be the minimized expression for this chord? Here the variable A is common, B is changing from B complement to B. Here C complement and C. Here C is changing from C complement to C and D is as it is. So the minimized expression for this is A complement D. Okay. For this, the minimized expression of will be AB complement. Why? Because the value of CD is changing from C complement to C and D complement to D. So we will absorb this CD and the output for this Boolean expression will be AB complement. We can make the chord like this also. If there are 2 ones here, 2 ones here, so we can make chord of it. If one are on the corner of this K-map, then we can make chord of this also. For this expression, for this group, the output of this group, the Boolean expression will be B and D complement. For this corner, it will be B complement, D complement. Okay. Now how to group octet? Octet is a group of 8. So if there are adjacent ones like this, if there are adjacent ones like this, if ones are here and here, then also it can be octet. If ones are here in this row, then also the octet will be happen. Here also, if ones are here and here, we can make a rolling of this K-map here like this. If ones are here and here, we can make the octet of it. The output of this octet will be B. Why it is so? The value of C and D is changing from C complement to D here, and the value of A also changing from A complement to A. So the output of this octet will be, the mean term for of this octet will be B only. Here also the AB value of AB is changing from A complement to A from complement to its original value. Here the value of D is common and value of C also changes from C complement to C. So the mean term related to this K map will be D. Here it is the some example, numerical example. If this is the Boolean function, we will make the entry like this. We can make the group a pair of these two ones, pair of this one and this one. And this one cannot be paired with anyone because there is no adjacent 1 to here. So this will be a single one of the group of single one. So the related mean term for this one will be AB complement C. For this red colored pair, the minimized expression will be A complement C. For this blue colored pair, the minimized expression will be A complement B. So the minimized Boolean expression for this expression will be like this. Okay. Here it is the another example. If Boolean function is given in this manner, then also we can make the entry. This is also a valid Boolean expression. Here are the mean terms given M0, M1, M2, M5, M13 and M15. Okay. So we can make the entry of 1 related to this mean terms. Here it is M0, here it is for M1, here it is for M2, here it is for M5, then M13 and M15. So how we will make the pairs? This two pair, this two ones for pair, and here it is ones for pair. If we will make the pair of this one and this one, then a redundant group will be appear, and the related Boolean expression for this will be like this. Here it is another example. The Boolean expression can be represented like this also. Okay. So here we can make the group of octet here. Here it is for pair and here it can be for chord. We can reuse this one and this one. Okay. We can make a note that if we are making a group of 2 to the power x number of ones, means if we are using octet, so we are making the group of 8 ones, that will be 2 to the power 3. So we can absorb the x number of variables. It means 3 variables can be absorbed. Suppose in this octet, we are making group of octet. So it means 2 to the power 3. So 3 variable will be absorbed for using this octet. Now here the function of 4 variables and the minimized expression is only of 1 variable. Okay. So we can note this. I hope you have understand this. Thank you very much.